Hey friends, welcome to the academic video for the glider plane project. In this video, we're going to be dealing a lot with force, which if you remember is essentially how objects move around. Force is a push or a pull. And obviously in airplanes, there's a ton of moving parts and they're really heavy, so it's all about balancing out the forces. There's 4 key ones that we're going to look at to see how they work together and help planes fly. The first one we're going to talk about is also the simplest. It's the gravitational force, which pulls the airplane back down. Obviously, airplanes don't want to go down, they want to fly up, so gravity hurts us. We just mentioned that airplanes are super heavy. For context, I'm about 180 pounds, so it doesn't take much to get me off the ground. But airplanes, on the other hand, are about 175,000 pounds, so it takes a lot of upward force to get those off the ground. We're going to touch on those upward forces here in a second. The other force that airplanes have to fight off is called the drag force, and a big reason why plane tickets are so expensive is because of the cost of jet fuel. It requires a ton of fuel and a ton of power to get those airplanes off the ground and resist the drag forces in the air. Have you ever stuck your hand out the car window and glided it through the air like this, but the second you turn it over, the wind catches it and pushes it back? That's a great illustration of what's exactly happening with drag. And here's the formula that tells scientists what's going on. Essentially, all it tells them is that the more surface area there is, that means the more chance there is for the air to hit it and push it back. And that's exactly why planes are shaped the way they are, with their long and skinny and aerodynamic structures, and why engineers are always experimenting with new shapes and materials to help further reduce that drag. But real quick, drag isn't exactly always bad. Can you pause this video and ask yourself, when might drag be helpful? And here's a hint, it's towards the end of the typical flight. That's right, planes need to decelerate from hundreds of miles per hour to 0 when they land, so they make their wings able to flip up and catch the wind to help slow them down when they land. So we mentioned that all these forces work together, right? And we already talked about what brings the plane down and what holds it back. But what about the ones that help it? Let's kick that off with one called thrust. Thrust is what launches the plane forward, and on a typical aircraft, that comes from the massive, super expensive and powerful jet engines that you see underneath the wings. We don't exactly have millions of dollars to spend on those jet engines, so our thrust comes from our hands, and we're going to give it a good forward push, which we'll talk about in the next video, and hope the forces balance out and make for a good flight. So now we've covered everything from what brings it down, holds it back, propels it forward, but what about what lifts it up? Well, that force is called lift. Without specially engineered wings in the shape of an airfoil like you see over here, lift wouldn't be possible. How it works is that when wind hits that airfoil, it sends the air above and below the wing at different speeds. I know this can be hard to wrap your head around, but the air that gets pushed below the wing gets a higher pressure, while the air above the wing gets moved to a lower pressure. And did you know that objects naturally want to go from areas of high pressure to low pressure? Just like this bottle cap, which is experiencing a high pressure inside the bottle and a low pressure outside. Let's see what happens to it. That cap moved as far and as fast as possible away from that high pressure zone to the low pressure zone. And that's exactly how airplanes work too. They want to move straight up out of the high pressure zone below the wings up to the low pressure above the wings. So they essentially get sucked up. Well, there you have it, friends. As soon as the thrust and the lift force outnumber the gravity and the drag force, you get liftoff.